Okay. So, what was the question?
The question is, do you favor performance for your ROS master or network reliability of your ROS master?
Okay, so actually it would be network reliability. Would be the best bet to have. So you have your robot, right? Then you have this link that should be, of course, bidirectional, you hope it would be, to say your cloud or your other computer. So what Nico is asking is, do you put the ROS master here? Or do you put it here? So the different nodes that will be run, they need to contact the master at all times or everything dies. So our original method for doing the cloud operations were actually to start everything as far as the master goes on the cloud. And on the robot, you'd say, hey, my master is over there on the cloud. So the master's IP address is some parameter you get to set. And you also have a couple other parameters you need to set to make this work. But you can say that your master is on the other machine. If you lose connection anytime, or the connection gets slowed down to the point that because a whole bunch of people are, on YouTube or something, some part of the school, or tapping on an app or something, I don't know what they're doing. But so this link breaks for any reason long enough for this connection to be broken. What happens is everything dies. So you're presenting to a whole bunch of people, you're showing, oh yeah, I can do all this network stuff with my robot. And then your connection gets lousy at one point. And then all the programs on your robot die. Hopefully. Because then you're going to go back and start them up again saying like, oh, let's reset the connection, make sure everything's right. You may have like a little zombie program or something going on because maybe your program doesn't die nicely. So then you have to use a script that I created which kills everything on your
ROS kill.
ROS kill. Kill all ROS, I think I call it. So I have a script called kill all ROS. I just call it ahead of time. Like in my scripts, I say kill all ROS and then start the stuff you want to run. It clears everything out, wipes everything else, there's no little zombies. Zombie is actually an official term in Linux. If you don't believe me, look it up, zombie Linux. So a zombie is basically a program that cannot be killed. You keep on killing it, it doesn't die. So if you have a program like that, it's not necessarily a zombie, but this program's off on its own, it's still trying to shut down, trying to fail, but it doesn't happen. So for Nico's question, it's actually better to have masters in both cases. Which, if we go back to that one node diagram, basically the master has all the different nodes over here. And then you have whatever you're going to do to basically take whatever data is coming in and send it over out. But you also have a synchronizer. There's a package, if you want to do this kind of work, called ROS Multi-Master FKID. It's just one of several, but I think it's probably one of the better ones. That syncs the list of topics. So you have all the different topics you're publishing, all the different ones you're subscribing to. It syncs the two of them together on both machines to make a more complete list that is the combination of this one and that one. Which also gets you in problems because you may have more than one robot called robot. Because you're not creative. Or you're lazy or something. Something forced you to name a robot or whatever it is. So then you don't actually have like a complete list. So you have two different robots and they're both named the same thing. That list does not get twice as long. Or this times 2 long on that side. So you end up with the problem that you have to actually namespace out your robot. Maybe you call this one robot 1 and one robot 2. You have to change all your topics accordingly. which I have an example, because that's what exactly I was doing on here. So the whole point of the robot that, sorry guys. So the whole point of the robot that I created for my dissertation, this guy, was to work with another robot. So this robot had a very creative name called Cleaning. The one's name was Walkie. So we're not creative at all with names. If you guys can think of better names, please tell us. Otherwise, we use Terminator style names, which probably won't be that nice and whatever. So this one is actually with the namespace of Cleaning. So in different cases, maybe you have a Kabuki Turtlebot 2, which should have some of them. You may want to call it Kabuki 1, Kabuki 2, Kabuki 3. But we happen to have 4 of these Turtlebots. So we thought Ninja Turtles would be probably a good name to give them. So we can namespace them out, like Leonardo, Donatello, Raphael, what's the last one?
Michelangelo.
Michelangelo. We can namespace them out to be those different names. So you have Michelangelo, camera image raw for the camera feed. But when you're synchronizing several different robots, you may need to say, I don't want all the information that you have. I just want what I care about. So maybe all they really need to do in terms of sharing is share their position with each other. Say like in a formation of robots. You have several robots that just need to share their position. You don't need them to share their camera feeds with each other necessarily, unless you want them to. So you can actually filter out what you don't want using that multi-master FKE. And there's a whole write-up on it. You can figure out everything about it. But it's doing basically the same thing I told you before. There's a ROS master on each node, and they have a synchronization and a master for a discovery of the different nodes. But overall, it's a very useful package for doing multiple robots or multiple computers. So this could be used for the cloud guys as well. The cloud guys can put ROS and put multi-master FKE and synchronize all their nodes and get past using some of these other maybe antiquated message passing programs that may not actually have better performance than what they want to have. So, good question. Sorry for the long explanation. But yeah, because of the internet communication issue, I would say that having a master on each node is the best way. But we have had issues. Basically, a robot just stops moving or crashes or something. So if you have to go run after a robot that continues to move because it lost input, you're not going to want to do that again. Especially when the robot breaks or cracks or something. That happens to it. For quadcopters, that's even worse. There are some people that I will make reference to off camera that do very funny things with quadcopters and not providing input. But that's a whole different story. Come see me in the lab if you want to know more about that. So, right here is that multi-master discovery and synchronization thing that I was talking about. Okay, so talked about all this stuff. Let's go back to the presentation mode. So back to some common problems and misconceptions about ROS. The actual question, I installed ROS, where is it? Where is the icon? It's not just like you double click an icon and go, ROS. It doesn't do that. You wish it did. You wish it kind of like helped you.
Well,
like,
you
hold
can't
your
work
hand
on
and tell the way I wish it did for me. But it doesn't do that. Whatever kind of holding your hand kind of thing, you have to develop that yourself. So you can make all your GUIs and everything you want. But up until the point of, I installed it, I can't find it, how do I find it, how do I open ROS? We might just smile and tell you, don't open ROS. You use it. It's like a whole bunch of tools that you use. So it's a collection of programs that helps you manage your robot's operations. So I showed you the image view. That's one thing. Transforms, another thing. Air track all-bar, which is third party, another thing. You have all sorts of stuff. I can't even tell you what's all in ROS. And I can find the page that has everything that's compiled, but that probably won't be everything. I probably have some other stuff that I haven't made public that could be part of ROS. So the ROS command for copying a file, I can't find it. ROS is in Linux. I didn't find anything in the tutorial about copying a file. Now I'm mad at you for showing me ROS. It doesn't help. That's kind of on you. You have to learn Linux to get to use ROS. You have to learn how that command line works to start typing in the things to use ROS. And then another thing, it's kind of just like the previous one. I reboot my computer, it doesn't come up in ROS. That's not ROS, it's Linux, Ubuntu, and open. So those are actual questions. And some of them may actually show up again, but I'm just trying to show you guys ahead of time what some of these problems are. This is actually quite often that we get the statement that I don't want to do these. I am bored. These ROS tutorials are so boring. I don't want to do them. They're so, it's a waste of my time. I just want to run my code. How do I do that? Well, I just point them back to the tutorials. So if I do that to you, that's just what's the case. I can't show you everything that you skipped and learning yourself to show you how it works. And I can do it real quick, but you won't pay attention probably well enough to see everything that I did. Unless you're like, by recording it basically. So when we tell you to do the tutorials, if you want to use ROS, please do the tutorials. At least the ones I tell you to go through. You can skip some of them that I can tell you to not do. But please do them. So why do you need to learn about creating folders, creating packages, creating all this stuff? Say you have some code that you want to run. What package is it in? If it is code. It's not in a package. To run any sort of ROS code, you need a package. Put it somewhere. Because that package has some information about how you're going to run it, with what libraries you're going to run it with. Even for Python, you have to add that kind of information. So it needs to know what you're linking it to make it work. So the reason why you need to learn about folders, writing code, running it on a simulator, is basically the same reason we're sending you to the tutorials. Because that's a lot of what's going on here. Installing, configuring your ROS environment, navigating the ROS file system, creating a ROS package, building a ROS package. Right about here, people come back and complain. Even some of our better researchers in the lab, they've come and complained like at the very beginning. Like, I don't really want to do this. Is there like a fast track? I'm like, yeah, go back to what you're doing because I can't help you on every single statement and typing it in for you. So understanding all these different things. You can probably skip number 9. I've never used it. It's just another way to basically foxhole you into thinking that ROS is Linux. It doesn't help. So this one is just an extra one. If you guys want to write that down, or I'll put it in the next lecture. So then here you can kind of decide if you're a C++ guy or a Python guy. Which one are you? So at that point you may decide like, I really don't understand that C++ stuff, or I really hate the way Python's looking because I like how C++ works. By that time you choose. And luckily for you, just about everybody, well, OpenCV is actually compatible with Python. Point cloud library, if you're going to try to do anything with point clouds, which are those things back here with these items right here. This is a point cloud, or these virtual items. Point clouds, you kind of have to know C++, because those are needing the performance enhancements of actually using C++ and compiled code. Otherwise, it's not really going to work that well. Recording and playing back data, you can try it, may not work on everybody's computer, but there are such things as like bag files. They're just a collection of all the topics that you want to put in the bag, and you can play back the stuff that wasn't in the bag. And this is exactly what you think it is. Basically, what happened in my system? What's wrong? Probably the best, the funniest command is. Is there any time for the next class? Okay, then basically, if you do most of these except for maybe 17, number 9, you can probably get away with doing most of them. So, they don't ever spell it out, but it basically means exactly what you think it means. Basically, where are the problems in your system? So what it'll actually do is tell you some things like, basically, nodes are not connected. Or maybe there's a problem with your package path, which I can get more in detail next time. Okay, so find yourself, I guess your takeaways from all this are basically find yourself a good tutorial for Linux, one that'll help you get through doing the different steps that you see in the ROS tutorials. I provided one of them. Of course, you have to pick and choose how much you can do in whatever amount of time. And then sometimes just throw yourself into the problem and see if you actually know what you're doing. If you don't know what you're doing, look up the commands, try to figure out what they are, and then proceed from there. But the last misconception I have here in the presentation is that any version of ROS and Ubuntu will work together. So maybe you're the kind of person who decides, I need to get the latest, greatest, the last version that they just put out like yesterday of Linux. That won't work. It probably won't work at all. Because ROS and Ubuntu releases are kind of really tied together. So for instance, I really like to use 14.4.3 Ubuntu and ROS Indigo. There are steps online if you want to try and install it before the next class. If not, I may actually just do an installation of a ROS next class for the first part of the class. If you try to do 14.10, you're really wasting your time. 15.10, unless you're going to try to use Jade for some reason, you're probably going to waste your time. So please listen to this. This is actually the reason why most people have problems in the first place installing ROS. Is that they choose the wrong version of Ubuntu, they don't listen to the suggestions, they don't read what is put on the installation guide. Which whenever you finally get to the ROS wiki, you're going to see installation, you get started. If you want to pay the money, you can do contributions. It'll land you at ROS Jade. You probably want to click this and go to ROS Indigo Igloo. And then choose your platform. So you can tell basically if you're using Ubuntu or one of these little ARM processor boards, you can use Ubuntu ARM HF, but I would really suggest if you're using a little board, like a Raspberry Pi or Odroid or BeagleBone or whatever else you have, that you look for pre-compiled, the pre-built images that are ready to go for your platform that have ROS on them. It'll save you a bunch of time. So then, right here, if you're at Indigo installation Ubuntu, which you can just type that in actually, you should be at the right place. And then you have to read at this point. You can't just copy everything that's in here. So that's basically what you're going to be doing. There are some steps to say, basically, do not type this in. You may want to follow that. Seriously, I plead with you, don't come to me and tell me, I typed all this stuff in too. Just because you can't read doesn't mean that somebody should fix your problems. So please, read what's being stated. If you don't understand it, ask somebody, look it up, whatever you're going to do. So when it says here, ROS Indigo only supports these packages and these Ubuntus, listen to it and read it or whatever, and pay attention. But these commands, just copy and you put it into your command line, and you basically have it. But don't copy this stuff unless you have that issue. And then you would choose ROS Indigo desktop or a desktop installation like a laptop or something.
Is there a way to install it via homebrew or? I don't know how to do it like for any combat, how to do.
Oh, yeah, you're just going to do some other method?
Yeah.
So if you want to compile it, or?
Yeah, exactly.
So if you want to compile it, you can actually get, the compilation steps are kind of shown with more in this one. Where was it? There are steps for doing it for source, it's just really not preferred.
Okay.
But if your platform already has, like whatever you're going to install, it actually has basically the image ready, I would just do that.
Okay.
I mean, for this one, I just download the Ubuntu image, or the ROS Ubuntu image, or Odra, and then just use it. I skip maybe several hours, because ARM processors are not that fast at compiling code, even with data processors. So there is actually some Android support, which is really good. We've had some people actually use it. It's going to be ROS Java. So I think that maybe Nico might be the one to ask about that in his class.
Maybe,
Maybe.
if I can remember.
Yeah. There's a lot of steps and it's really kind of backwards, but it sort of works. But what you end up getting with that would be control over your robot from your phone in an easier manner. So you just basically launch an app and you just control it from whatever method you want to control it, be it the IMU, or if you have like a remote control program you design that you want to use, you can do that. If you don't even want to do that and you just want to make something yourself that's not ROS on the Android phone, you can still do that as well. You just have to know how to communicate between your phone and the non-ROS program. And non-ROS commands for actually doing that. Unless you want to adhere to the ROS message format in your own program. So, you guys have any questions on, just basic intro ROS and where we're going from here? I can tell you. But next class we're going to actually dive down into one of these boards and do some work. It'll be that on my computer. I'll just set it up in class. It'll be kind of fun. So, 2 birds with 1 stone. Any questions? Hope that didn't alienate the cloud guys. We'll be doing a little bit of Python next time. I'm going to roll into this one, but there's enough, at least on the intro, to ROS in the next level. Yes?
What is the concept of a bash RC file? How is that?
Okay, so say like every time, let me see if I have to send my terminal up. Oh, my session expired. Okay, so the bash RC file contains all your settings for every time that you have a new terminal. So right now, there was a bash RC file basically that was ran. It may not be called bash RC because it's probably a different version. But you see that CG conf, this line right here. This is probably going to be the different parameters that were provided to this emulator. So bash RC is kind of like the same thing. It's kind of like your basic setup, your default settings. So for instance, if you want to always have something added to your path, you would set it in your bash RC file. So that would be one place you'd probably put the catkin development bash file that you have to put into your bash RC file. And if you install ROS, you know what I'm talking about. But that'll come later for those that need to take quick tutorials and go through it. But the bash RC is just basically the settings you want every time you open the terminal. So it's actually ran that many times. So if you open up 50 windows, you have 50 different times you ran bash RC. Any other questions? Concerns? Maybe like, I don't know what Linux is still, or? No?
Is the PowerPoint going to be on Dropbox or Blackboard?
Is what?
The PowerPoint that you're using?
Yeah, it's gonna go up on Dropbox, I believe.
Oh, okay.
I think the video is gonna be on YouTube. No? It's gonna be made available. I don't know how it does it, but it does.
You can check your Dropbox folder, Intelligent Robotics folder in Dropbox. Actually, almost all of your lecture notes, presentations, and other sources, papers, textbooks, all of them are in the Dropbox folder. You just need to dig a little bit, look for it.
Are you going to put videos on Blackboard instead?
No videos.
Fill my Dropbox again.
No videos in Dropbox either. No.
Okay, you can press them.
If you want, you
Well, you don't want
can
to see what
come
it's
and
like.
find me. I will be in Ace.
Yeah.
Just find me, I can give it to you.